All right. Homework from topic 1. I think question number 3. None of you have done this correctly. So let's have a look at the solution here. Okay, so first of all, how many points of intersection can two circles have? When two different circles are there, they can have at most 2 intersections, right? And then we can add some lines there. Each line can meet each circle in at most 2 points, right? For example, we can put a line here and also a line here, right? Well, note that you want to make number of intersections the most. So each line must cross with each circle and the other lines. And then we can add another line here, right? Each pair of lines can meet in at most 1 point of intersection. This gives us 3 more intersection points, and 1 for each of the 3 ways. We can choose 2 of the lines to intersect. This gives us a total of at most 2 plus 12 plus 3, right? Which equals 17 intersection points in total, right? So if you count the numbers here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and oh, sorry, my bad. Missing one here, 16 and 17, right? Any questions? Okay, and I think there's no questions for the other homework here, right? So let's have a look at topic 2. Okay, for topic 2, I think the first one is number 5. Okay, some of you have done this incorrectly, so let's have a look at that. Three straight lines intersect as O, and angle COD equals angle DOE in the diagram below. The ratio of COB, which is here, to angle BOF, which is here, is 7 to 2. What is the number of degrees in angle COD? So since the ratio of angle COB to angle BOF is 7 to 2, there is some x such that we can let angle COB equals 7x, right? And let angle BOF equals 2x. Then we have 9x equals angle COF, right? Which equals 180 degrees. Then this gives us x equals 20 degrees. Then we know angle COE equals, COE BOF. Yes, angle COE equals angle BOF, which is 40 degrees, right? And finally, since angle COD here equals angle DOE, we have angle COD equals 1/2 of angle COE, which is 20 degrees, right? Any questions? Yeah, sometimes the diagram is not necessarily drawn to scale. That's why we need to prove the theory, right? Okay, next one. Number 6. Okay, so given line WV is parallel to line YZ and WZ is parallel to VY, which is shown here in the diagram, find X here. Okay, so we know if these two lines are parallel with each other, then we can label this angle as 40 degrees, right? Because they are the same side interior angle, which adds up to 180 degrees. On the other hand, we know this angle here equals 90 degrees minus X, right? Because we know this angle is here 90, and 180 minus 90 gives us 90. So we have 40 degrees plus 90 degrees minus X plus 3X should equal 180 degrees, right? Again, because they are the same side interior angle. So this gives us an equation with respect to X, which means 2X equals 50 degrees and X equals 25 degrees, right? Do not forget to specify the unit. Otherwise, when you measure an angle without a unit, by default they mean radians. So you don't want to use radians here. We'll talk about radians later, okay? So here, if you want to use degrees, do not forget to specify the unit here. Okay, if you have any questions, just interrupt me, okay? Otherwise, we'll see the next one. Number 7. Some of you haven't done this correctly. So we have two parallel lines, and you need to find the value of X here. So basically, you can draw an auxiliary line here, which is parallel to either L and M. Then immediately we know the three lines must be parallel with each other, right? So we can label this angle here as A, label this angle here as B. Then we know A equals 180 degrees minus 130 degrees, which is 50 degrees, right? And B equals X because these two lines are parallel and the alternate angle should equal with each other. Then we know A plus B should equal 90 degrees because we have a right angle here. Then this gives us an equation in terms of X, which means 50 degrees plus X should equal 90 degrees, right? And this means X must equal 40 degrees. Of course, sometimes the method is more than one, right? You can compare yours with mine, see which one is better. Okay, next one is number 9. Show that angle A equals angle C and angle B equals angle D in the diagram below. Okay, of course the question itself is straightforward, so be careful with your discussion here. You need to write your analysis in the formal mathematical language. So you should write it like this. So first of all, line AB, note that these two arrows indicate these two lines are parallel, right? So line AB is parallel with line CD. So this gives us angle A plus angle D equals 180 degrees, right? Because they are the same side interior angles, and angle B plus angle C also equals 180 degrees. On the other hand, line AB is parallel with line BC, and this gives us angle A plus angle B equals 180 degrees, and angle D plus angle C equals 180 degrees. So let's label them with equation number 1, 2, 3, 4. Then in order to have angle A equals angle C, we can use equation number 1 and equation number 3. From these two equations, we know D must equal B, such that the left side equals the right side, right? So from these two equations, immediately know we know angle B equals angle D. From the other two equations, number 1 and number 4, we know angle C must equal angle A must equal angle C, right? All right, the next one, number 12. Okay, find the x in the diagram below. All right, note that angle ABC here equals 30 degrees, and BDE is also 30 degrees, right? So this indicates these two lines are parallel with each other. Again, as I said, in the diagram, it's not necessarily to scale or to the real situation. As you can see here, apparently these two lines seem to intersect some point here, right? But you need to use mathematical theories to prove whether they are intersecting at some point or they are just parallel. So apparently here we have alternate interior angles are equal. This indicates these two lines must be parallel with each other, no matter how the diagram is drawn, right? So we can say angle ABC equals angle BDE. Well, you could say because then you have AB, line AB is parallel with line DE, right? Then we have angle BAC here, this angle equals X because there's a corresponding angles, right? Corresponding angles should equal, which is 180 degrees minus 122 degrees, right? Therefore, we know X equals 58 degrees. Any questions? No? Okay, next one. Question number 19. Given that angles have the measures indicated in the diagram, prove that AB is parallel with CD and BC is parallel with AD. So you should write it like this. First of all, angle ACD equals, here you can find this angle, right? Which is 180 degrees in total in the triangle ADC, minus 30 degrees minus 80 degrees, which gives you 70 degrees. Therefore, these two angles are equal, right? And then you could say, because angle ACD equals angle CAB, we have line AB is parallel with line CD, right? Again, alternate angles are equal, indicating parallel lines. Because angle DAB equals 30 degrees plus 70 degrees, which is 100 degrees. And angle DAB plus angle ABC equals 180 degrees, right? And we can have BC is parallel with line AD because same side interior angles adding up to 180 degrees indicates parallel lines, right? Okay, have a look at the solution here. Any questions, just let me know, okay? And otherwise, let's have a look at the next one. Question 23. Okay, another typical angle chasing problem. Find x in the diagram. Okay, note that we have a pair of parallel lines. AB is parallel with CD, right? Therefore, we know angle C here must equal angle B here, right? Therefore, we know angle C equals 3x. So this angle is 3x. And also because BC is parallel with DE, we have angle C plus 5x plus this angle here should equal 180 degrees, right? And this means angle C is 3x. 3x plus 5x equals 180 degrees, which means 8x equals 180 degrees. Then we know x equals 180 degrees over 8, and this gives us 22.5 degrees, right? Again, just use the properties of parallel lines can help you solve the value of x here. Okay, next one, number 23. The measures of the angle in the diagram below are marked. Find angle C here. So let's call angle C. Okay, need to find the value of angle C. So, okay. We have line AC is parallel with line BE, right? And therefore we have okay, again, these two arrows indicate these two lines are parallel with each other. Therefore, we have angle ABE equals angle BAC. ABE here equals angle BAC. Because they are alternate interior angles, right? So here, this angle must equal 3x, which equals 3x. And angle ACB then equals 4x minus 3x, which is x, right? This is x because this is the exterior angle of these two angles. So 4x equals x plus 3x, right? So we immediately know that angle C or angle ACB equals x, and angle ABC equals 360 degrees minus this is 360, right? Minus 4x minus 2x plus 2x plus 3x, which is 360 degrees minus 9x. And then we know in this triangle here, triangle ABC, the sum of the three interior angles should equal 180 degrees. So we know angle VAC plus angle ABC plus angle ACB equals 180 degrees. Angle BAC is 3x, angle ABC is here, 360 degrees minus 9x. And angle ACB is angle C, which is just x, right? Again, you have one equation in terms of x, then simplify that equation, gives us 5x equals 180 degrees, right? And therefore x equals 36 degrees. Well, x is just angle C, so angle C equals 36 degrees, right? Yes?
Why is like angle C X?
Why is angle CX?
Yeah.
Yeah, because this angle here is 4x, right? In this triangle ABC, the exterior angle equals the sum of the two remote angles, right? Again, the method could be more than one. You can compare yours with mine and choose optimal one to solve the question here. Okay, have a look at the question here, and any questions, just let me know, okay? And our next question to discuss is 25. Okay, 25 is a little tricky. Well, you can actually draw a diagram to illustrate the situation here. Suppose we draw a clock here. Okay, we need some auxiliary lines to help us locate the two hands. Okay, so in terms of hours, this is 12 hours, and then this is 3 hours, then 6 hour, 9 hour, right? But in terms of the minute hand, we also let's mark all of the hours then. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12, right? In terms of the hours hand, these are the marks of the hours. But in terms of the minute hand, let's use another color. This is 5 minutes, right? And then 10 minutes, 15 minutes, then 20 minutes, 25, and then 30, 35, then 40 minutes, and then 45 minutes, 50 minutes, 55 minutes, and then we have 0 or 60 minutes here, right? And 0 or 12 hours here. Okay, so the question asks us to find the angle between the two hands when we have 11:10 p.m. Okay, 11:10 means your hour hand must be somewhere. Okay, let's first locate the 10 minutes. 10 minutes must be here, right? Exactly here, right? This is 10 minutes. Okay, this is a minute hand. And how about the hour hand? Could it be here? Not exactly, right? Because you have already 10 minutes past 11. So the hour hand, hourly hand must be somewhere here, not exactly to the 11 hour here, right? There is a slight angle here. So your task is to find the angle formed by the minute and hour hands, which is, well, let's label some points. Let's call this point A, C, O. Let's call this point D, and then this point is B. Okay. So as long as you can find this angle, then you can find this angle, because first of all, we know this angle is 1, 2, 3, 3 of 12 times 360, right? You see that? Okay, first of all, angle BOC equals 3 over 12 times 360, which equals exactly 90 degrees, right? So next, let's find angle AOC. Angle AOC equals, okay, that depends on where is your minute hand, right? Your minute hand already suppressed 2 of 12 times 360 degrees, right? So that means your hour hand should already pass 2 over 12 times the angle COD, right? Can you follow me? Which is 1/6 of angle COD is just a 1/12 of the whole revolution or whole turn, which is 360 degrees, right? So that gives you 1/6 times 30 degrees, which equals 5 degrees. Then we know angle AOB, which is angle you're looking for, is angle DOC. Sorry. Is angle BOC minus angle AOC, right? Which equals 90 degrees minus 5 degrees, which is exactly 85 degrees. So not 90 degrees, but 85 degrees. Can you see that? Neil? Can you follow me? Leo? Are you there? Are you still there? Okay. Oh, I mean, Leo, not Neil. Sorry, I confused it. It's the two names of you. All right, so have a look at the solution here. Any questions, just let me know, okay? And I think we'll have a look at one last question of your homework, which is question 27. if you know, have no problem with this. 27, last one. Okay, first of all, there is no diagram, so probably it's better to draw the diagram by yourself. So first of all, let's draw a diagram to illustrate the situation here. You can, well, when you sketch a diagram, it's not necessarily to scale, okay? That'll save you a lot of time. As long as you keep all the elements in their correct relative position, you should be fine. So basically, we have a triangle here, PQR. So let's call this is a point P, this is a point Q, and this is a point R. Point Z or Z on side PR. So let's call this point Z or Z, which is American English. And we know angle PZQ is here, equals angle PQZ. PQZ is here, right? And angle PQR minus angle PRQ equals 42 degrees. And you need to find angle RQZ. RQZ is here. So you need to find this angle here, right? So we don't know that angle. Usually you can call this angle X. Well, in order to facilitate our discussion, let's call this angle theta. Then this angle is also theta, right? And then let's call this angle R, or angle beta. So here we have angle PQR equals angle PQR is theta plus x, right? Then we have angle PQR plus x. Sorry, angle PRQ, not PQR. Angle PRQ. Then plus x equals theta, right? Because theta is the exterior angle of the two remote angles, right? So this means oh, actually we don't need this letter here, so let's just use angle PQR. PRQ plus x equals theta, so this means angle PRQ equals theta minus x. And then, well, let's call this equation number 1. This is equation number 2. And this is equation number 3. So from equation number 1 to 3, we can have theta plus x minus theta minus x equals 42 degrees, right? Because PQR is theta plus x, and PRQ is theta minus x, right? So just insert these two expressions here respectively, and again we get one equation in terms of x, which means 2x equals 42 degrees, and of course x equals 21 degrees, right? Therefore the angle you're looking for, RQZ, equals 21 degrees. Okay, these are the typical questions in our previous homework. Do you have any questions? Any other questions you want to discuss here? No? Okay, then let's have a look at today's lesson, okay?